Hi and welcome to Chemipedia chemistry classes for 11th and 12th standard. So in this video I am going to discuss a simple trick to find bond order of polyatomic ions. Polyatomic ions, charged species which are made up of more than one atom, which is called polyatomic ion. So the simple formula, bond order is equal to total number of bonds divided by number of bond locations. This is the formula what we are going to use here. Okay, right. The example number 1, carbonate anion. So I have drawn the resonance structure of carbonate anion. Right. So here between carbon and oxygen we have one double bond and two single bonds with net charge 2 minus, isn't it, right? But here number of bonds are about 4. The bond order formula, number of bonds divided by number of bond locations, isn't it? Number of bonds are 4. Here 2 plus 1 3 plus 1 4, isn't it? Divided by number of bond locations. This one, this is 2, this one, this is 2, this is the third one, isn't it? Number of bond location is about 3, about 4 by 3, so 1.33. Okay, for carbonate anion, bond order is about 1.33. Okay, then the second example, the nitrate ion. What is it? Nitrite actually. What is it? Nitrite ion at O2 minus, isn't it? Right now this is the structural formula of nitrate ion. So here nitrogen, oxygen, between nitrogen and oxygen there is a double bond and a single bond, isn't it? Right. And nitrogen carries a lone pair also, right? So number of bonds here 2 bonds and here 1, but total number of bonds is about 3. Bond locations 2. So this is first location, N double bond O. This is second location. But number of bond location about 2, but 3 by 2, so 1.5. Okay, so nitrate ion bond order is about 1.5. Okay, then the next one, phosphate ion. Phosphate ion formula PO4 3 minus. So this is the structural formula of phosphate ion. And one more point you have to note down here. The negative charge is equal to the number of single bond. Here you have 2 minus charge, which means there are 2 single bonds between carbon and oxygen, isn't it? Similarly, in nitrate ion, the net charge is minus unit negative charge, isn't it? So that there is only one single bond between nitrogen and oxygen. Okay, now look at this phosphate anion, which has 3 minus charge. In the sense, there are 3 sigma bonds between phosphorus and oxygen. Okay, these are the 3 sigma bonds between phosphorus and oxygen. The other oxygen is bonded through a double bond. Okay, right. Now, so bond order formula as usual, number of bonds divided by number of bond locations, isn't it? Okay. Number of bonds totally 5, isn't it? 3 single bonds and 1 double bond. For number of bonds totally 5 divided by bond locations. There are 4 phosphorus oxygen bonds. There are 4 phosphorus oxygen bonds, isn't it? Right. So that bond locations are about 4. 5 by 4 is nothing but 1.25. Okay. So that the bond order of phosphate ion, bond order between phosphorus and oxygen, bond order between phosphorus and oxygen in phosphate ion is about 1.25. Okay, right. Then the next example, sulfate anion. Sulfate anion. So formula SO4 2 minus. So look at the net charge 2 minus, which means here we have only 2 single bonds between sulfur and oxygen, 2 single bonds. Then other 2 oxygens are bonded with sulfur through double bonds with net charge 2 minus. Okay. Now the formula, number of bonds divided by number of bond locations. Number of bonds 6 because 2 single bonds and 2 double bonds. So total number of bonds will be about 6. Number of bond location 4 because there are 4 sulfur oxygen bonds, isn't it? There is 2 sulfur oxygen single bond, 2 sulfur oxygen double bond. But total bond location is about 4. But number of bonds 6 divided by number of bond location 4. 6 by 4 is nothing but 1.5. Okay, right. So this is how to calculate the bond order of polyatomic ion. I hope you understood how to calculate it. Right. Thank you and keep watching other videos. Okay, thank you very much.